Hello everyone, in this video we're going to talk about the insemination and the pregnancy models in our daily app of the eFarm integrated farm management system. My name is Peter Evans. If you're new here, don't forget to hit that subscribe button as well as also ringing that notification bell. So the insemination model tracks the inseminations that have been performed in our farm, as well as the pregnancy model tracking the pregnancies that have resulted from those inseminations. And this useful information can be used to make decisions about breeding strategies, herd management, as well as even fertility monitoring. And so, without wasting much more time, let's jump straight into our PyCharm IDE and see their implementation. Over here, you can see we have our pregnancy as well as the insemination model open and ready for us to explore. So, first up, our pregnancy model over here has these several fields, that is a cow. So this one shall actually associate each and every pregnancy record in our database with a specific cow. It has a start date, the date of calving, the pregnancy status, pregnancy notes, the calving notes, pregnancy scan date if that's applicable, the pregnancy fail date if the pregnancy actually failed, as well as the pregnancy outcome. So I believe all these fields are quite descriptive, and maybe if you have issues of whatever they actually stand for, you can just ask that in the comment section and I'll gladly answer you. Then now we shall be extending the default objects manager with our custom manager, the pregnancy manager over here. So our managers.py actually have these new managers for today's tutorial, that is the insemination manager as well as the pregnancy manager. So I'll start by this one, where we have this method, the pregnancy duration. So this pregnancy duration shall be returning the number of days that have actually elapsed since the start date of that pregnancy. So if the date of calving is availed as well as also the pregnancy outcome, so that technically means that that pregnancy has actually ended, then we shall be returning the ended string, because it makes sense that way. There is no way we shall be returning just the pregnancy duration of pregnancy records that have actually ended. So I hope you understand that rationale over there. And then we have the due date method over here that shall be returning the expected date of calving, that is the pregnancy start date plus the 285 days. So 285 days is the average gestation period of most of the cows. So it makes sense that if the pregnancy starts, let's say today is 1st September that I'm recording this video, 1st September of 2023, then we shall have 285 days. So that shall be the expected date of calving. And in the cases where the pregnancy has actually ended, we shall as well be returning the ended string over there. We also have this method that is the latest lactation stage. So this one shall be returning the latest lactation stage associated with that cow. And if the cow, let's say the cow is a heifer and does not have any lactation stage associated with it prior to this pregnancy record, we shall be returning the no lactation statement. We also have these several methods, that is the get confirmed pregnancies, unconfirmed pregnancies, failed pregnancies, successful pregnancies, miscarried pregnancies, as well as also stillborn pregnancies. So basically how this operates is just by filtering the pregnancy objects that we have in our database based on these fields, that is the pregnancy status. So that is actually the return value for this method over here, where this method, if it's called, actually it shall be returning pregnancy objects that we have in our database that actually have their pregnancy status choices as confirmed. The similar principle applies to all these others. And so that's it for the models. So we have a property over here. So basically this property shall be just be calling the pregnancy duration over here, so that we actually get the value of which, if the pregnancy shall be ongoing, we shall be getting a integer value, and if the pregnancy has ended, we shall be getting just the ended statement. So similar thing applies to this latest lactation stage property over here. And then now in our clean method, just like from the previous tutorials, we are performing several validations, that the validation based on the age, validation based on the cow current pregnancy status, validation based on the cow's availability status. We are also validating the dates, validating the pregnancy status, as well as also validating the outcome of the pregnancy. So we shall just go ahead and check about in our validators.py. Yeah, so you can see over here we have our pregnancy validator. So because these methods are so many, I won't go through them. I'll just quickly go through maybe one or two. So this one is fairly simple, so I'll just collapse it as well as this one. Then you're also performing validations based on the cow availability status, so that is also fairly simple. So validating the pregnancy status over there. Then now I see this one is a little bit longer and it has a plethora of parameters. That is the start date, the pregnancy status, the date of calving, the pregnancy scan date, as well as also the pregnancy fail date. So the first check is on the start date, where we ensure that the start date is not in the future. Then we also ensure that the date of calving and the start date are actually validated, where the date of calving must be greater than the start date, because it makes sense that whenever we are keying in a pregnancy record, the date of calving shall be future. So that technically means that it must be greater. If that's violated, or rather the date of calving is less than the start date, shall be having the date of calving must be after the start date, error raised. Then the date of calving as well must not be in the future, because also does not make any sense. Then we also ensure that the date of calving that is provided minus the start date must be within the range of the 270 for the lower limit and 295 for the upper limit days in between. So I told you about the average gestation period of a cow is around 285 days. So giving it 270 for the lower part and 295 for the higher part makes a lot of sense, because most of cows will give birth within that specific window period. So if that's actually not the case, where let's say you want to provide a date of calving of maybe pregnancy duration of 200 days, does not make any sense, this error shall be raised. And then for the scan date also, we perform some validations where we ensure that the scan date, since it's always in future based on the start date, then this error shall be raised. We also now ensure that the scan date is not in future. And by the way, you might be wondering the reason why we have this date method called over here. The reason I do so is that the pregnancy scan date is a datetime object. Then the today's date that we have from our utils.py over here is a date object. So you see, we shall be having the type error if we just do the direct comparison over there. And you see, by applying the date method on this datetime object, we shall be converting the pregnancy scan date to a date object, so that Python does not give us a lot of errors over there. Then just like the gestation period, where we are checking, actually this one over here, where we're checking that the date of calving minus the start date must be between 270 to 295 days. We do the same thing for the pregnancy scan date, where we ensure that the scan date must be between 21 to 60th day after the start date, because it makes no sense, by the way, that you perform a scanning of a cow, or rather do your pregnancy scanning just, let's say, 10 days after the start date of the pregnancy. Actually, by that time, even the embryo has not actually even developed, so you won't even notice if there's some development over there. And probably 1 month to maybe 2 months after the start date, you might notice something. Then we now perform validations based on the pregnancy fail date. We ensure that the fail date, if it's availed, it must not be in future. We also ensure that the fail date must be greater than the start date, the same rationale as the others that I've explained just some few seconds ago. Then we ensure that if the fail date is availed and then the pregnancy status is not actually failed, so we shall raise this error, because if the fail date is availed, the pregnancy status must also be failed. Then we also perform some checks over here, where we ensure that the fail date must only be confirmed 21, or rather the 21st to 295th day, that window period from the start date of the pregnancy, because there is no way you can say that the pregnancy has failed just 2 days after the alleged start date of that pregnancy. By that time, you won't even notice that, okay, this pregnancy is either botched or stuff of that kind. And then we also have the validate outcome over here that actually takes in the pregnancy outcome, pregnancy status, as well as the date of calving as its parameters. So it's performing validations based on these 3 fields over here. So first up, we check if there is the pregnancy outcome, and then the pregnancy outcome is not within the values that we've actually specified, then we shall throw this error. Then we also ensure that if the pregnancy outcome is there, and actually the pregnancy outcome is amongst either the live or maybe the stillborn, then the pregnancy status must be confirmed, because technically the pregnancy outcome of live and stillborn means that the cow has actually undergone their complete gestation period, and so the pregnancy must have been confirmed. And then if the outcome is live and we do not have a date of calving, there is no way, by the way, a cow can give birth to like a live cow, then we do not have a date of calving. So that's, it's just rational, just like that. Then we also ensure that if the outcome is a miscarriage, the pregnancy status must be failed. Now you understand that. Then we also ensure that if there is a date of calving and the pregnancy outcome is not amongst the live and the stillborn, then we shall throw this error, provide the pregnancy outcome. And so that's it for whatever we have in our current pregnancy validation. So we shall now go ahead and now get back to our models.py. So of course we have the save method that is actually calling the clean to ensure that all those fields are validated during the save of the pregnancy. Then now we have the insemination model over here that also have several fields. That is the date of insemination, that is automatically locked, by the way. We have the auto now add is equal to true parameter specified over there. We have the cow field that is associating a specific cow to each and every insemination record that is in our database. Then we have the pregnancy over here. So this shall associate a pregnancy record to an insemination, and you can see it's a one-to-one field, which means that each and every pregnancy must be only tied to a single instance of insemination, and maybe a single instance of insemination can only be tied to a specific record of pregnancy. So I hope now you understand that. And by the way, if there is an attempt for a deletion of pregnancy record that is associated with an insemination record, then there shall be an error raised. So that is actually the protected error. Then now we also have the success field, the nodes, the inseminator that is associating a specific inseminator. From the previous tutorial, I talked about the inseminator and the heat models. So each and every insemination record must be associated with a specific inseminator. Then we also have the semen that is actually associating a semen record in our database with the specific insemination record, just as well as whatever we had in our inseminator, pregnancy, then the cow as well. So we are also extending the functionality of the default objects manager over here, where we have a custom manager that is the insemination manager. So back to our managers.py. Then up over here, we only have a single method that is a day since insemination. So this method shall be returning the number of elapsed days from the date that there was an insemination. So I hope you understand that. So this is just similar to whatever I had actually explained about the pregnancy duration. So back to our models, you can see now we have a property over here that shall be returning the number of days since insemination. And then the clean method shall be performing validations based on the days, that is the validate within 21 days of the previous insemination. And then we also have one here, validate already in heat. So back to our validators.py. Yes, over here we have our insemination validator. So these are the two methods, the validate already in heat. So we ensure that a heat object must be associated with that cow within the observation time range. So the date of insemination must fall within the range of 12 hours ago and right now. And if that's actually not the case, we shall be raising the error of the cow must be heat at the time of insemination. And then we also have the validate within 21 days of previous insemination, where now we ensure that for each and every 21 days cycle, there's only a single insemination record that is associated with a specific cow. So the rationale over here is that the cows, by the way, they are always in heat cycles ranging from 18 to 24 days. So averagely 21 days makes a lot of sense. So that's what's happening over there. So I hope by that we're done with the models that we're supposed to talk about today. That's the insemination as well as the pregnancy model. So I'll just collapse them, and then now we shall head over to whatever we have today in our signals. So in our signals today, I've actually enhanced the signal of the create lactation, and right now we are checking, by the way, if we do not have the date of calving and then the pregnancy outcome as well is not within the pregnancy outcome choices of it's either alive or maybe a stillborn, then we shall now proceed to execute other codes. And so the else part of this evaluation over here technically means that there is the date of calving as well as the pregnancy outcome is either alive or stillborn. So that technically means that the cow is actually supposed to lactate. And now first up we mark the cow. So I added a new method over here, mark a recently calved cow in our cow manager. So back to our managers.py over here. This one was not in the previous tutorials, by the way, so I'll just quickly show you it. You can see we are in our cow manager over here. So I'll just collapse these methods. Okay, here we have it, the mark a recently calved cow. So we ensure that that cow's category is now marked as a milking cow, because there's a validation check in our lactation that shall ensure that each and every cow that has its lactation record must be a milking cow. Then we also ensure that the current pregnancy of the cow is changed to the calf. So this one shall ensure that the cow is marked as calved, so that some operations shall also be performed based on its pregnancy status of the calf. Then now we save that cow. So back to our signals over here. Sorry. So now that we've actually marked the cow, we now perform some try and accept catch block, where we check if the cow has some associated previous lactation. So this one shall work for maybe cows that are actually given birth, maybe the first, the second, the third, and then the fourth. So this one shall only be available for cows that actually have the previous records of giving birth in our farm, where we check if there's a previous lactation associated with that cow. We shall retrieve it and then check if it does not have an end date, and then assign that end date to the date of calving of that cow. Remember, we have the instance over here that is actually a pregnancy instance, because this method over here, or rather this signal over here, listens to the post-save of pregnancy. So the instance over here is a pregnancy, and remember our pregnancy has the date of calving as its field, so we shall subtract 1 day. So this technically means that if our cows give birth today, then we end the previous lactation the day before today, and then we save that, and then we create a new lactation object, or a new lactation record with respect to the data that is actually associated with that instance, where the start date shall now be the date of calving of that cow. So this is the start date of a new lactation record, and then the cow shall be now the instance that's associated with that pregnancy record. Then of course we had also this field of the pregnancy, so we shall also now populate it with that pregnancy. Then the lactation number shall be now the previous lactation number added 1. So I hope you understand that. And then now the accept catch block here shall be the case for the cows that have actually not given birth, or maybe they do not have any lactation record in our farm. So this one actually, the lactation objects.filter, then we do some filtration over here, shall return the model does not exist syntax if. So in this case it shall be the lactation if it does not find anything. So that is what we are catching over here, where if that's the case, then now we create a new lactation object. So this technically means that these are cows that, for example, they are heifer, they are the first time calving cows. So the start date shall be now the pregnancy instance, date of calving. Then now the cow, of course, it shall be now the cow that's associated with that pregnancy, as well as now that pregnancy shall also be populated. And then now you might be wondering, by the way, where is this lactation number over here? So our lactation model has a default of the 1s for the lactation number. So you already know that this lactation over here is the cases where we do not have any previous lactation being handled. So technically the lactation shall be the first lactation in our database. And then now we also have another new signal over here, that is the create pregnancy from successful insemination, where we shall be checking if the insemination success field has been marked as true and we do not have any associated pregnancy. Then we shall go ahead and create now a pregnancy object associated with that cow. So that's it for whatever we have in our signals. Now I'll go ahead and explain our serializers. So over here in the serializers, we have 2 of them, the Insemination Serializer as well as also the Pregnancy Serializer. So these are fairly simple. Remember, this is a property and it's a calculated field, so it will be a read-only field. And then now we go ahead and now customize the parent update method that is found within the model serializers. You can see we are inheriting the model serializer over here. So the goal of this is to ensure that all those other fields are excluded, because technically when we shall be updating the insemination serializer, the only field that we shall be expecting to change will be only the success field. Either it shall remain as false by default, or maybe marked as true if now the insemination is marked as successful. So I hope you understand that. And over here you can see that we are now actually using the list comprehension, by the way, to pop out all these fields. These are fields that are found within the insemination model. So sorry, once more. So let me expand it. You can see we have the date of insemination, cow, pregnancy, success, nodes, inseminator, as well as the semen over here. So in our serializer, yeah, you can see that that's what we are actually focusing on here. We are actually excluding them to ensure that only the success field shall be updated. And then in our pregnancy serializer over here, we are also inheriting from the model serializers. So the due date and the pregnancy duration are calculated fields, or rather they are calculated properties. So they shall be read-only. Then all those other fields we are performing serialization. So there's no any special stuff as at now, but maybe in future I shall consider maybe refactoring the logic inside here. So that's it for our serializers.py. So in our permissions over here, you can see that we've added several permissions, that is, they can act on insemination records. So actually the insemination record shall be restricted, or rather the activity of the insemination record shall be restricted to only the managers, that is the farm owner, the farm manager, as well as the assistant farm managers. All those other people shall either get the forbidden response, or maybe the authentication failed if actually the person is not logged in. And then for our pregnancy permissions, we have one, can add pregnancy record. So this one is restricted to only the farm owner as well as the farm manager. Then we also have the can view pregnancy record. So this one shall be available for all the farm staff, that is the farm owner, the farm worker, the farm manager, the assistant farm managers as well. Then for the updation of the pregnancy record, that is restricted to only the farm management, that is assistant farm manager, the farm manager, as well as the farm owner. Then for the deletion of the pregnancy record, that's only allowed for access to the farm owners as well as the farm manager. So that's it for our permissions that we have today. Now we head over to the views.py, and in our views.py, let me just collapse these ones we had actually talked about in the previous tutorial. Today we have our insemination ViewSet over here. So you can see we are actually activating the filtration as well as the ordering. From the previous tutorial, I know that right now these ones are not like foreign, or maybe the concept over here is not new to you. So we shall be ordering based on the date of insemination, success, as well as the cows. And since we only had a single permission class, we just apply it directly over here. Then now we also override the default list method in our model ViewSet to ensure that if we actually supply the query parameters, then all that is affected. So the two scenarios are covered over here, where if we supply the query parameters and those ones that does not actually filter anything from our database, we shall have this error, or maybe this response message of the no insemination records found matching the provided filters of an HTTP status 404 not found. Or maybe if there's no insemination record in our database, then we shall return the no insemination records found over HTTP status 200 OK. If there's something, then we shall now actually serialize them, then now return the response of that serialized data. We also override now the update logic of our insemination record to ensure that the success field is the one that is actually updated. So one thing that I realized is that if you actually just go ahead and then specify only this update over here, that is actually now raising the method not allowed, then it will also restrict the partial update. So that's something that I've realized with the model ViewSet. So you have to specify whatever we want to do over here, where we shall be restricting the put. So you see, the reason why I'm doing this is because the put method requires like all the fields to be supplied in a HTTP request in order to like perform updates to the insemination record. And remember, our insemination record only expects the success field to be updated, and the rest, of course, our serializer shall also handle that, but we also actually ensure that that is also handled at the view level, where now for the partial update, that is the patch request, so that shall be handled. Then on deletion, or maybe on a deletion request, we ensure that if there is an associated pregnancy with an insemination record, then we raise a 403 error of the deletion not allowed. Insemination record has some associated pregnancy with it, and if that's not the case, then we shall go ahead and then perform the destroy of that insemination instance that is actually deleting it. So that's it for our insemination view set. And then for our pregnancy view set, so the rationale and the logic is just the same. So we are also now activating the filtration as well as also the ordering. So we shall perform ordering based on the start date. And by there, I also have the filter set. So just a minute, I'll show you whatever we have in the pregnancy filter set as well as also the insemination filter set. So over here, we are actually applying the permissions that we have in our permissions.py. So the first case for the creation, we are only allowing the farm management, that is a farm owner, as well as also the farm manager to add new pregnancy records. And then if we are to perform, let's talk of updation, then only those who are allowed to perform the update to the pregnancy record shall be granted that ability. And then if it's about deletion, then only the farm owner as well as the farm manager shall be able to perform that. And then if it's about, let's say, listing or maybe retrieving, then they can view pregnancy record, which actually entails all the farm staff. So those are the permissions for our pregnancy view set. And then now, just like in the insemination view set, we are also overriding the default list method, where we ensure that if the query parameters are associated with that request and there's nothing that is actually filtered from our database, so we shall be returning no pregnancy records found matching provided filters of this status, the 44 not found. And if there are no any pregnancy records in our database, we shall return no pregnancy records found of the 200 OK status. And if there's something over there, of course, our parent serializer method shall be called and it shall actually serialize them. And by the way, the main is equal to true actually tells this serializer that we have. So you can see we are actually accessing the self-get serializer. So this is like, the default serializer method that is found within our view set that shall actually go ahead and then now use the pregnancy serializer that we have over here. And then now the main is equal to true tells the serializer that sometimes there might be many pregnancy objects that is associated with that in the database. Then now we return the response of that serialized data as well as also the status. So that's it for our views. So I talked of the filters.py. So touching on it a little bit, so we shall be able to filter based on the cow, the inseminator, success fee, the date of insemination, year of insemination, the month of insemination, the week of insemination, the day of insemination. That is for the insemination filter set. Then for the pregnancy, we shall also be able to perform the filtration based on the cow, the start date, the year, the month, pregnancy fail date, pregnancy outcome, pregnancy status. So by the way, I think there's still a lot that we can add or maybe delete or maybe just refactor and modify over here, but that's a story of another day. And so that's it for the today's code. So as usual, shall go ahead and now run the tests, and in our test folder, dairy folder, then in the test. So in the test views over here, I've actually added very many tests over here. The ones that are associated with the insemination, as well as the one that's associated with the pregnancy. So since there are many, I'll only just be like touching through a few of them. So first up, we are testing addition of a pregnancy record as a farm owner, where now we send a post request to this URL over here. I had told you about the reverse resolving all this. So it shall be something like, okay, the local / dairy / pregnancy / maybe add and stuff of that kind. So we shall be sending a post request to this URL with the request payload of that pregnancy's data. So from the previous tutorial as well, I had talked of now availing all this data in our conf.test.py. So this one shall be the fixtures. And of course, we specify the format of that. Then now also avail the HTTP authorization token of the farm owner, since this one is testing the addition of a pregnancy record as a farm owner. So we shall be doing that. And then now after that, we check that the response status code is 201 created, that is that pregnancy record is added, and then we check if that pregnancy object is actually existing in our database. So we also now go ahead and now check if the addition of pregnancy record as assistant farm manager is actually not accepted, that is the permission denied. So if an assistant farm manager is actually trying to do such stuff, then the HTTP for 3 forbidden status shall be raised. Then since these ones are so many, I'll just go ahead and then also explain about the updation of the pregnancy as a farm owner. So over here, we send now a patch request to this URL, the pregnancy records detail. We also specify the primary key of that pregnancy, that is that pregnancy ID. So the request payload over here shall be now the update data. Then just like the post request, the format will be the JSON format, as well as also supplying the authorization header token. So this is the update data. And by the way, you have to be very keen that we had a lot of validations over there, where we had the pregnancy status, the pregnancy notes, as well as also the pregnancy fail date. So one thing that I might tell you over here is that if this pregnancy status is failed, the pregnancy fail date must be availed. And by the way, all those other stuff, for example, if we supply maybe 300, 400 days that are actually like returning negative, I mean, they are like less than start date of that pregnancy, then we shall have that error. And by the way, if time allows, I'll go ahead and maybe play around with those validators and show you how they actually behave. But for now proceed to the Insemination ViewSet, that is testing of the Insemination ViewSet. So just like the pregnancy over there, we are now sending a post request to this URL with the request payload of that inseminations data. As well, this one is in the conf.test.py. So all this stuff are just working in a similar perspective from whatever I've actually explained over there. So even over here where we have the test update insemination as a farm owner, so that's what's actually happening over there, where we supply now the update data dictionary of the success is equal to true. So this technically means that we shall be marking this insemination as successful, and then also we supply the nodes of the updated nodes for the insemination and stuff of that kind. So, and then now we assert that the response status code is 200 OK, of which that is always the response status code of like successful updates. We also ensure that the success is the same as whatever we have actually passed over here, that is true from the response, as well as also the dictionary that we've passed over here, and all those others as well. So that's it for the testing of the Inseminations ViewSet. And then now we also have one final test over here that we shall be trying to test the deletion of an insemination record that has some associated pregnancy with it, where if that's the case, then this one shall be raised, that is the HTTP forbidden status. And of course, now you understand that if we try to delete an insemination record that actually has associated pregnancy, then we shall have this error. So I've talked about, by the way, showing you whatever the errors that our validators raise. So I'll just quickly, before I run the test, let me just collapse this, and then now I'll just simply go ahead and then let me just comment this out. I'll just leave that one test first of all to run. Then all these others, I'll just like comment them out first of all, and then show you whatever I was actually talking about. So comment all this out, and then all these previous tests as well, comment them out. So collapse this, and then now we run the test. So sorry, so it shall be PyTest. Seems like there are some other tests that are actually not commented out, but well, there's no problem, just let it run. So oops, it seems that there are so many. So actually, let me check how many. It collected 35 items. Ouch, those are so many. So I'll just have to actually check them out. Where are they? Oh, seems like I actually did not comment them out, so let me comment it out again. So back to our test over here. Now, since I've now commented it out, and actually they have all passed as you've seen, so back to it. And then now let's talk, for example, actually we say that the pregnancy status is failed, and then we do not avail the pregnancy failed date. So trying running it. Yeah, and then you can now see pregnancy is marked as failed, so we have to provide the date of failure. And if you are, let's say, to comment this back, then now comment this one. So if we run that, you can see the pregnancy must be failed if the pregnancy fail date is provided. So you can see that that's actually the operational principle, or rather the importance of actually performing the validations and stuff of that kind. And so without wasting much time, I'll actually just comment these ones back and actually now let them be as they were. Let me first of all check if all of them are there. So let me just take them back, and yeah, sure, these ones are back now. Nice. So these tests are so many, probably, yeah, it's 2,100 lines of code. So now it seems like every test is back. Just have to confirm them. So back here now, we run the tests. Probably it will take some more time. All right, barely in 3 minutes, we've actually ran our 168 tests, and all of them have passed. And that marks the end of this tutorial. So if you find it actually useful and helpful, please consider subscribing, sharing, and also if you have some question, please don't hesitate to ask that out. And so I'll see you in the next one. Bye bye.